Hi guys, welcome to this video tutorial on how to perform data analysis on the videos we collected during the locomotion data collection experiment in order to perform kinematics analysis. So some of you may be wondering what the hell kinematics are, some of you may have already looked into this. But just to give a quick definition, kinematics are a branch of mechanics which are concerned with the motion of objects. Okay, so kinematics are the features or properties of motion of an object, or in this case, an animal. So this can be as complex as trying to understand the motion or the moments acting around the joints of an animal's limb while it's moving, or it can be as simple as just trying to understand the stride characteristics of an animal. So by this, what I mean is characteristics such as stride frequency, stride length, time that the foot spends on the floor, or the time that the foot spends off the floor. Now, for the purpose of this assignment that you're currently writing up, we're only going to focus on stride frequency as a kinematics parameter. And what you're going to need to do is link that concept of stride frequency with the energetic cost of locomotion of an animal during movement. So to do this, we're going to analyse the videos using a program called Tracker. If for whatever reason your computer doesn't support that program, then please work with one of your friends to do this. Okay. So I've already got Tracker open, and this is basically what it looks like. There are some other files which you're going to need to get, and these are on Moodle. So if you go to Moodle and scroll to the Assessment Information tile, you'll see a folder called Locomotion Videos and Kinematics Analysis. If you open this folder, you'll see a series of videos. So we've got all the videos of the participants that walked on the treadmill, and we've got 3 videos of each speed that we used. So we've got 3 videos for 2.8 kilometers per hour, 3 videos for 3.8 kilometers per hour, and 3 videos for 4.8 kilometers per hour. So as you analyze these videos, you're going to need to click on these and just save them somewhere in order for you to be able to open them in Tracker. Okay, so what I've done is I've already downloaded them all and put them into a folder. So you're also going to need to open this kinematics analysis Excel spreadsheet. So let's just enable editing, and this is where you're going to do all of your actual number crunching, your data analysis. Okay, so there are several spreadsheets in here. You've got one for data analysis, and this is where you're going to put your actual stride frequencies that you record for each video, and then you can calculate your averages in terms of mean and your standard deviation values in order for you to make the correct graph to display this data. And there are some spreadsheets for each speed as well. So there's one for 4.8, there's one for 3.8, and there's one for 2.8. We're going to leave it on 2.8 kilometers per hour for now because that's the speed that we're going to start with. Okay. So when we do our video analysis, what we're going to do is paste the data from that analysis into here, and then that's going to enable us to be able to calculate that stride frequency value that we have. Okay. So just to kind of introduce that concept here of stride frequency, basically stride frequency is measured in terms of hertz, so it's number of rotations per second, okay, or in this case, number of strides per second. So it's calculated as the number of strides, which we're going to enter in here in a minute in cell B2, divided by the total number of time that we observe our strides to take place. Okay, that'll become a little bit more clearer in a minute. So now what we can do is switch over to our Tracker program, and from here we're going to drag into this space, okay, the first video that we want to analyze. So when it opens that video, sometimes some of the lines are a bit grainy. So what you can do is you can just zoom in and out just by using 2 fingers on your mouse pad. And sometimes that graininess sorts itself out. Okay. So now we've got our video uploaded to Tracker. I'm just going to talk a little bit about this space, right? This program space, some of the functions we're going to use it for. Right. So first of all, we can move throughout the video swiftly by using this slide bar at the bottom here. Right. Or we can move through it frame by frame using these buttons over here. So I can click on these buttons and it'll move the video forward or backwards. So when we record a video using a camcorder or using a phone, it records that video at 25 frames per second. And what we can do with this Tracker program is click through this video frame by frame. So what we want to do, in order to be able to calculate stride frequency, the kinematics parameter we're interested in, is we want to collect data on 5 strides. Okay. Just to reiterate what I mean by stride begins when the foot contacts the floor and that limb that's attached to that foot starts to become load bearing, and it ends when that same foot does a complete rotation and becomes a main load bearing limb again. So just to explain this using this video, I just click through this. Okay, let's focus on this leading foot here, the front foot, the foot closer to the camera. Okay, it starts to contact the floor here. Make good contact with the floor here. And about here we can see that actually it's flat on the floor, the foot's flat on the floor, the limb is nice and straight, and the other foot is starting to leave the floor. At this point we can say that the stride has begun. Okay, then it ends when this leading foot does a complete rotation and ends up back at the same position. Okay, so the foot's flat on the floor, the limb's nice and straight, and the other foot is leaving the floor. Okay, so we want to collect data on 5 of these. Now, to do this, we need to create a new track. So we go up to the top here and click on the Create button, and then click Point Mass. Okay, this will now enable us to be able to actually collect some data on this video. Alright, so to start with, let's just click through this video using these buttons down here until we are happy that the stride has started. Okay, so the start of the stride is around here. I'd say that's quite indicative. Okay, so we've got a nice flat foot, nice straight limb, the other foot is leaving the floor. And what we need to do, we need to put a data point on the front of the foot here. And to do that, we press Shift. If you press Shift, you'll see that a little square appears. And whilst holding Shift, you just click your mouse, and a data point will appear. Okay, and we can see that over here. Okay, so we've got time that the data point was created, and we've got X and Y. Okay, so X is our horizontal view, and Y is our vertical view. Okay, we're not actually interested in X and Y here, we're only actually interested in time in order to calculate stride frequency. Remember, as I said a moment ago, stride frequency is calculated by the number of strides divided by time. Okay, so we've got our first point there. Okay, so that's the point when the stride has begun. Now what we need to do is just click through. Okay, we need to put another point on the toe as it starts to leave the floor. So the last point when it leaves the floor. So it's already left the floor there. So we're going to put a point on the toe here. And then we're going to keep moving through until that foot is flat on the floor and that limb becomes a main load-bearing limb. And then we'll put another point on the toe, and that's one complete stride. Okay, it's one complete stride, and we need to do that for 5 strides. So let's just keep working through. So I'm going to put another point on the toe just as it leaves. And I'll put it on toe. So each time you kind of press shift, you can then let it go again to move through the video. You don't have to keep holding shift all the time. Okay, so now I'm going to press shift again and put another point, and I've let go of shift again now. I'm just moving through the video. Okay, until we get to 5 strides. Just got one more to complete. And the last point then is the foot breaks contact, becomes a load-bearing limb. We now have 5 strides. Okay, now if we want to just double check that we've got 5 strides, we can just count the number of points up here. Right. So 1, 2, 3, 4, 5. So each of these represents a full stride. Okay? Okay, so now what we need to do is copy the data from this table over into our Excel file. And we only need the time data remember. So you literally just kind of highlight it and press Ctrl C. That will copy it. We can then switch over to our Excel file. Make sure you're in the spreadsheet for speed 2.8 kilometers per hour. And I've just written up here in the cell A5, paste time data here. So if you click on that and then click Ctrl V, that will paste your time data in. So what we've got here then is the data that we've copied over from Tracker. Okay, so this is the times that the strides took place over. And here actually we've got the point where the foot made contact with the floor, became a load-bearing limb, and the point where it left the floor. I'm not actually interested in this data here. This would be used to calculate another kinematics variable, such as stance time or swing time. Okay, what we're actually interested in is stride frequency, which is simply the number of strides divided by total amount of time that we spent recording data on these strides. Okay, so it's quite simple. I've put the calculations in here already for you. All you need to do here is enter the number of strides that we actually observe. Okay, so it's 1, 2, 3, 4, 5. So we literally just put a 5 in there and press enter, and it will calculate stride frequency for us. Okay, so stride frequency, number of strides per second. Okay, once you have that, we can then copy over this value of stride frequency, so Control C, into our data analysis spreadsheet. You can't paste it straight in because it's a formula. So what you need to do is right click and go to paste special and then paste it in as a value. Okay, and then just to complete that, go to format cells, and remember we really only want to place everything at 2 decimal places. Okay, that's our first data point for our first video, and you basically need to do that for each video. Okay, as you do it, the more you do it, it'll get quicker. Okay, it shouldn't take too long. Then once you've got that, you can calculate the means for each speed and the standard deviations for each speed. Okay, good luck guys.